Polynomial expressions routinely need to be operated upon, typically through things like addition, subtraction, multiplication, and even division of polynomials is possible. In this video, we'll review the first three of those operations. In order to add or subtract polynomials, all you do is combine like terms, and by like terms, I mean things that have the same variables and the same variables to those same exponents. Any coefficient in front is combined through addition or subtraction as appropriate. So looking at this first example here, I look for like terms. I see 4x squared, 7x squared. They're both terms with x squared. I have 4 of them here. I have 7 of them here. So all day I'll have 11x squared. Next terms I'm looking at is minus 2xy, and another minus 2xy here is being added to it. They are like terms because they both have an x and a y in the terms without any other exponents in there. I have negative 2 of them and minus 2 of them here, so subtracting the coefficients, I'll have minus 4xy. Then I look for remaining terms here, 5y cubed. And then 6y here, these two are not like terms. They have different exponents, so I can't combine them. I just have to keep both of them, minus 6y. Now let's look at subtraction of two polynomials. So now I'm going to have this complicated looking one. And notice its coefficient is square root of 2 here. That's a real number. That's fine. The other coefficient over here is pi. By pi, I mean the real number 3.14, etc. It's a coefficient. Don't treat it any differently like you might 7. Now I'm subtracting these two things, so I look for like terms. And I need to remember here to subtract them. So distributing the sign through, it'll be minus root 2 minus cubed root, and both of them are x to the 5th. So those are like terms. Then I have minus 7x cubed, and then I'm going to distribute the minus here. I'll have another minus 7x cubed. Notice it looks plus here, but to remember to distribute that sign. Next one is pi x, and then I have to subtract pi x. And then I have minus 6 here, and I'm going to subtract another minus 6. So I just organized the calculation, but now I'm going to actually do the subtraction of those like terms. And in the first one, you can't really do much. You have square root of 2 and you have square root of 3 being subtracted away from them. The coefficient will be this awkward looking expression, square root of 2 minus the square root of 3 times x to the 5th. Don't expect that to simplify any further. This one is going to be minus 14x cubed. Observe that the pi x cancels with the minus pi x, so we don't see that one, and the remaining term is constant, minus 12. Now let's turn to multiplication of polynomial expressions. Our first example, we'll take 2 times x to the 5th, and we'll multiply by the polynomial here in parentheses. And you just treat this expression like you would any real number expression. And if you wanted to multiply this through, you would have to distribute that term in front across each of the terms in parentheses. When we're doing that, we're multiplying powers together, and so exponents will add. So I'll have 2 times 4 gets me 8. And then I'm going to take x to the 5th times x squared. Those exponents add to x to the 7th. I'm going to have 2 times minus 7, so that gets me minus 14. And again, adding the exponents, x to the 5th times x to the 1st gives me x to the 6th. And then finally, multiplying this by 1 doesn't change the term at all, and I have 2x to the 5th. If the expressions involve multiple terms, then you have to distribute every term against every other term. So what I mean by that is this term would have to be distributed against this, and then this would have to be distributed against this, and then everything needs to be simplified, any like terms combined. This is a very special and famous case of such a situation where the two expressions being multiplied together are called binomials. There's 2 terms here, and there's 2 terms here. And binomial multiplication has this famous method called the FOIL method. So I'm going to follow that here and review that as we do. So what I do is I first look at the first terms in each binomial, 2x to the 5th, 4x squared, and I multiply them together. I get 8x to the 7th. Again, that's the product of the first two terms. I'm now going to look at the outer two terms, here and here, the outside on the expression. And I multiply them together and I get 4x to the 5th. That's the outer two terms multiplied together. You then look at the inner two, so the ones on the inside of the expression, that's going to give you minus 12x squared. Those are the inner terms multiplied. And then you look at the last two, here and here, minus 3 times 2 gets you minus 6, and those are the last. And as I mentioned, this is called FOIL for first, outer, inner, and last. Observe that all the terms here are different powers of x, so no further simplification is required. You should be familiar with certain special products, although I don't want you to memorize any formulas you see here, but at least recognize these examples. One of the famous products you should be familiar with would be the square of a binomial, something like x plus y squared. This just means to take x plus y times itself. And let's apply the FOIL method now. So I'm going to do the first two is going to give me x times x. I'm now going to take the outer x times y. I'm going to take the inner y times x. And I'm going to take the last y times y. The order that I multiply real numbers in does not matter. X times y and y times x are the same thing. And so there's two of those terms, and I'm going to combine them to xy. Similarly, if you were to do a difference and then square that, you would get x squared. And the only thing that's going to change now is that instead of having pluses here, when you do the outer and inner terms, you'll get minus xy, so you'll get minus 2xy. When you do the last two terms, because both of them have the minus in there, it will still be plus y squared. Now what happens if we were to mix these kind of expressions together? If I took x minus y times x plus y, now nice things will happen. When I do the first terms, I get x squared. When I do the middle terms, the outer is positive xy, the inner is minus xy. They're going to completely cancel out now, and we won't see those mixed terms involving x and y. And then finally, minus y times y gets me minus y squared. And this is called a difference of squares, and you should probably recognize this expression when you see it. That's a square, there's their difference, and that factors as a product, x minus y times x plus y. Let's look at one final example. Let's expand the following binomial, 4x squared minus 3 squared. Don't feel you should use this formula above, just work through the problem like we did above. I'm taking 4x squared minus 3 times itself. And let's apply the FOIL method here. So the first terms, when I multiply them together, will give me 16x to the 4th. I'm adding exponents. 2 plus 2 gives me 4. I look at the outer term. That will give me minus 12x squared. But there's two of them, so I'm going to double that because of the inner term. Minus 24 now. And then I look at the last term, minus 3 times minus 3 gives me plus 9. Everything is simplified, there's no more like terms to be combined, and there's the result.